Asynchronous programming is a fundamental concept in modern software development. It allows applications to perform multiple operations simultaneously, improving responsiveness and efficiency. In this lesson, we will explore how to execute operations asynchronously using task objects in C#. By the end of this lesson, you will understand how to create and manage tasks, handle their results, and understand their importance in building responsive applications. Don't worry if this feels new at first. Now we're on understanding tasks. A task in C# represents an asynchronous operation. It can be thought of as a lightweight unit of work that can be executed concurrently with other tasks. Tasks are part of the system. Threading. Tasks namespace and provide a simple way to perform asynchronous programming. When a task completes, it can return a result or indicate whether it was successful or failed. Creating a task. Let's dig in. To create a task, you can use the task run method, which takes an action delegate or a lambda expression as a parameter. This method schedules the task for execution on a thread pool thread. Here's a simple example. This slide introduces a class definition. Study the structure in the code sample. In this example, we create a task that runs a simple action, printing a message to the console. We then call task wait to block the main thread until the task completes. This section covers returning results from tasks. Sometimes you may want a task to return a result. In such cases, you can use the task T class, where T is the type of the result. Here's how you can create a task that returns an integer. This slide introduces a class definition. Study the structure in the code sample. In this example, the task computes a value and returns it. We access the result using the result property of the task. Let's move on to handling exceptions in tasks. When working with tasks, it's important to handle exceptions that may occur during execution. If a task throws an exception, it will be captured and can be accessed when you try to get the result. Here's an example. This slide introduces a class definition. Study the structure in the code sample. In this example, we create a task that throws an exception. We catch the aggregate exception that's thrown when the task is awaited, and we iterate through the inner exceptions to display the error messages. Now, using isync and await with tasks. The isync and await keywords simplify working with tasks, allowing you to write asynchronous code that looks synchronous. Here's an example. This slide introduces a class definition. Study the structure in the code sample. In this case, the main method is marked as isync, allowing us to use a wait on the task. This means the method will return control to the caller until the task is complete, without blocking the thread. In this lesson, we explored the concept of asynchronous programming using task objects in C#. We learned how to create tasks, return results, handle exceptions, and utilize the isync and await keywords for simpler syntax. Asynchronous programming is essential for building responsive applications, allowing you to perform operations without freezing the user interface. Go ahead and work through this exercise. First, create a task that simulates a long-running operation, e.g., sleeping for several seconds, and returns a message. Also, write a program that creates multiple tasks and waits for all of them to complete, then prints their results. Also, implement error handling in a task that divides two numbers, and ensure you manage division by 0 exceptions. Finally, convert a synchronous method to an asynchronous one using isync and await.